the masses m sub I are located at the points p sub I, we want to find the center of mass of the system given the three masses and the 3 points. So they're telling us that mass m sub 1 is located at point p sub 1, mass m sub 2 is located at p sub 2, and mass m sub 3 is located at point p sub 3. The formula for the center of mass, also called the centroid, is given here below, where m sub y is the moment about the y-axis, m sub x is the moment about the x-axis, and m is the sum of the masses of the system. Before we solve this problem though, I do want to talk about moments and also explain why, when determining the moment about the x-axis, we use the y-coordinates, and when determining the moment about the y-axis, we use the x-coordinates. Let's begin by looking at a one-dimensional system, as we see here, which is a teeter-totter. The measure of tendency to turn about the fulcrum is called the moment about the fulcrum of the system. In this system, the moment on the left, this side here, is greater than that on the right, this side here, so notice how the system would rotate counterclockwise. The moment between a mass m and a point is the product of the mass and x, which is a distance between the point and the mass. So notice the moment on the left would be 50 kilograms times 1 meter, giving us 50 kilogram meters. The moment on the right would be 35 kilograms times 1 meter, which would give us 35 kilogram meters. Again, the moment on the left is greater than the moment on the right, therefore the system rotates in this direction. Now I do want to mention, when we find the moments on a number line or the coordinate plane, we do use sign distances. And then finally, the center of mass of this system would be where the teeter-totter balances. Notice how we'd have to move the fulcrum further to the left. Now let's consider moments on the coordinate plane. Looking at this diagram on the right, if we want to find the moment about the x-axis, this axis here, notice how the y-coordinates would give us the sign distance from the x-axis. This is why when determining the moments about the x-axis, we use the y-coordinates. Looking at this diagram on the left, when we find the moment about the y-axis, notice how the x-coordinates give us the sign distance from the y-axis. This is why when determining the moment about the y-axis, we use the x-coordinates. So now let's go back to our example and find the center of mass of this system. Let's begin by determining m, the sum of the 3 masses. So m is equal to 7 plus 2 plus 9, which is equal to 18. Now let's find the moment about the x-axis, capital M sub x. So we'll take each mass and multiply by the y-coordinate of its location given by the point. So for the moment about the x-axis, we would have 7 times 6 plus 2 times negative 5 plus 9 times 8. Again, we had 7 times 6 plus 2 times negative 5 plus 9 times 8. So we have 42 plus negative 10 plus 72, which equals 104. And now we'll find the moment about the y-axis. So now we'll find the sum of the products of the masses and the x-coordinates. So we'll have 7 times negative 4, 2 times negative 3, and 9 times 9. So once again, 7 times negative 4 plus 2 times negative 3 plus 9 times 9. So we have negative 28 plus negative 6 plus 81, which equals 47. Now we have all the information we need to find the center of mass. So x bar comma y bar is equal to moment about the y-axis divided by m, comma the moment about the x-axis divided by m. So the x-coordinate of the center of mass would be 47 divided by 18. The y-coordinate of the center of mass would be 104 divided by 18. But notice how the y-coordinate does simplify. So we have 47/18, comma, 52/9. Let's view the results of this on the coordinate plane. So if we put these masses on the coordinate plane, their locations would be at these 3 points. And we found the center of mass to be this point here, where if we convert these to decimals, these would be the approximate values, and therefore the center of mass of this system would be at this location here, which means at this point the system would balance if we put a fulcrum at that point. I hope you found this helpful.